Jai Hind to all. Myself Yogan Naran Prajapati, Assistant Professor Ajay Kumar Garg, Engineering College, Ghaziabad. Today I am going to teach a very important topic of the theory of automata subject, that is minimization of the finite automata. This topic asked every year in university examination, and sometimes it is also asked the GATE examination. So we can say that this topic is a most important topic in the point of view for the university and GATE examination. Now, before studying the minimization of finite automata, first we discuss what is the deterministic finite automata. As we know, the deterministic finite automata have a 5 tuple: Q, sigma, summation, Q naught, and F. Where Q is a set of state, summation is known as the set of alphabets. This one is a transition function. Now this is the set of alphabet, set of input alphabet, and lambda is a transition function. The transition function is 2 to power q, where q is a inputs. Now q0 is a initial state. We can say that is the start state, and and you know very well that F is a final state, that is also a subset of the Q. Q0 and F is a subset of the Q. Now, for example, Q0, that is the initial state, that is the set of input symbol A, and we go to the Q1, and this is the final inputs. It means, and if we consider that is the finite automata, then what is the initial state? Initial state means, initial state is Q0, and what is the Q? Q naught and Q1 is your Q. What is the sigma? Sigma is A. What is the transition function for this problem? Transition function for this problem is Q0 A goes to Q1. Now, and what is the final state for this automata? The final state F is stands as the Q1. 1, 2, 3, 4. And what is the Q naught? Q naught is that Q0. Now, this is the 1, 2, 3, 4, 5. For this automata, we explain the concept of this. Okay, now let's move the better example of how to minimize the any problem into the minimization of the finite automata. We consider this is the example. Now, for this example, we find the Q0. Q0 is Q0. That is the initial state. What is the final state? Final state is for this problem is Q4. Okay. Now, what is the set of states? What is the Q? What is the Q? Q is a Q0, Q1, Q2, Q3 and Q4. What is the summation? That is A comma, that is the set of inputs. And what is the final state? That is Q4. move to how the any finite automata are minimized. When we minimize the any finite automata, then we follow the few steps. The step number 1, draw the transition table of the given finite automata. In transition table, that is state, and that is known as the transition table are designed with the help of two things, set of inputs and state. Now Q0, that is the Q0, we give the input on Q0A, then to move to the Q1. This is the method by which we design the transition table of the any finite automata. Similarly, on Q0B, we move to the Q2. Now Q0B, we move to the Q2 state, and on Q0A, we move to the Q1 state. Similarly, we design the transition table for all the state. On Q1, Q1A, we move to the on Q1, Q1B, we move to the Q3. No problem. Similarly, on Q2A, we move to the Q1, and Q2B, we again move on the Q2. No problem. Now, similarly on Q3A, move to the Q1, Q3B, move to the Q4, Q3B, move to the Q4. Now, in last, that is your final state. On final state A, move to the Q1, and on final state B, move to the Q2. So, this is the method for which we design the transition table of the given finite automata. That is our first step. Now, in second step, divide these all state into sets. Divide all these 4 states into the 2 sets. In set 1, set of all non-final state. It means that is the state. In set 1, all non-final state, that is the set 1. And in set 2, set of all final state, it means that is the set 2. Now we have the equivalence theorem. Now that is the P0, that is the set 1, and that is the set 2. That is a step for minimization of second step. All the states are divided into the 2 parts. Set of all non-final state and set of all final state. Now we move to the another state. Again these 2 sets divided into the subset. Divided into the subset on the basis of the transition function. It means these 2 sets, set 1 and set 2, again divided into the subset on the basis of the transition function. For which transition base we follow? Which state have the same transition function? This is the important. Which state have the same transition function? All states are into the same set. All states are into the same set. Okay? And which state have the different transition function are lie into the different set. That is the main concept for the step 3. Now, Q0, Q1, Q2 and Q3. Q0, Q1, Q2 and Q3. that is the set 1, and Q4 that is the set 2. Now we check the Q0 transition function and Q1 transition function. If these two transition functions are same, then lie into the same set. If these two transition functions are different, then lie into the different set. That is the concept. We check Q0, Q1 and Q2. If these three states have same transition function, then lie into the same set. We check Q1, Q2 and Q3. If these states have same transition function, then lie into the same set. Okay, now the transition function of the Q0 and Q2, check. Q0 transition function from A move to the Q1 and Q2 from A same movement are allowed. And for B, it is Q0 also move from Q2 and Q2 also move from Q2. It means Q0 and Q2 have same transition function. It means Q0 and Q2 have same transition function. Then it is lie into the same set. Now check these, how many sets are remaining? Q1 and Q3. We check the transition function of the Q1 and check the transition function of the Q2. If it is similar to Q2 or Q0, then lie into this same set. If it is different, then lie into the different set. If Q1 and Q2 have a same transition function, then lie into the same set. If different, then lie into the different set. Now first we check the transition function of the Q1. Q1 A move to the Q1 and Q1 B move to the Q3. Now and Q3. We underline this one and this one. Q3 from A is similar Q1 and Q2, but from B it is different. It means Q1 and Q3 have a different transition function. So it is not lie into the same set. It lie into the different set. It means Q1 have again a subset and Q3 is again a subset. And what is the transition function of the Q4? Already lie into the different set. Now this process is continue until two steps are not same. Until P2 and P3 are same, then this process has been stopped. And this is my final answer. Okay, now we again check this one on the basis of the transition function. Now we check this one. It means this one no further division is possible. This set no further division is possible. Q4 is single set, so it is not further divided into the subset. Only Q0 and Q2 we are going to check. If it is same, then lie into the same set. Okay. Now we check the transition function. Lie into the same set. Q0, the transition function, Q0, Q1, Q1. Now this is the Q1, that is the 1, 2, 3, 4. Now there are the 4 subset. Now the transition function of Q0 from A, it is Q1, it means lie into the same set. It is lie into the Q2. And for the Q2, same, it is Q1, it means lie into any, for A, Q0 and Q2, the same transition. And for the B, it is Q2, it is lie into the self set. And for both, it is lie into the same set. It means Q0, Q2 again have a same transition function. So it both set lie into the same set. Now we again this is no further checking because it is single set. It is further not divided. Q3 is not, Q4 is not. Now this is your final answer. It means Q0, Q1 have a single set, Q3 another state, Q4 have another state, and Q3 have another state. It means total 5 states are minimized into the 4 states. This concept is known as the minimization of the finite automata. I think it is a good example for the minimization of the finite automata. For the better understanding, we move now Q0 and Q2 are minimized. Q0 and Q2 are minimized. It is behave at the single state. Q1 have a different state, Q3 have a different state, and Q4 is a final state, that is different state. Now Q0 and Q2 are minimized, that is the single state. Now Q0, Q0 and Q2 from A move to the Q1. Q0, Q1, A move to the Q1. That is very easy. And Q0, Q1, Q0, Q2, B, Q2 पे. Now B from move to the Q2. This is the minimized finite automata. This is the minimized finite automata. And I think from we check Q1, Q3 and Q2. Q1, Q3 and Q4 are same, no changes. Now this state is known as the A, this is B, this is C, this is final state D. It means total 5 states are minimized into the 4 states. This is known as the finite automata, and we check the transition function. This is the next problem for the better understanding. I have repeat that what are the steps we follow. The first step, design the transition table of the given finite automata. Then what is the next step? All state divide into the 2 part, set of final state and set of non-final state. And what is the third step? Any whole minimization are classified into the 3 steps. Step 1, draw the transition table of the given finite automata. Step 2, divide the all state into the set of final state and set of non-final state. And step 3, these states are divided into the subset on the basis of the transition table. Okay. Now this is the state Q3. Q3 state, it is unnecessary, we remove. Now this is your final finite automata. And how many state is final state? Q1 and Q2, no problem. Then what is the first step? Very simple. We design the finite automata, and I already discussed how to design the finite automata transition table. Now Q0A, Q1, Q0B, that is Q0, no problem. Now from Q1A, that is Q2, Q1A, that is Q2, and Q1B, that is Q1. Self loop. Now Q2A, that is Q1, and Q2B, that is the self loop. Now we divide into the set of final state and set of non. Now this is the set 1 and that is the set 2, that is the set 1, because Q1 and Q2 are the final state. Now divided into the two state, this is set 1 for all non-final state and set 2 all final state. Now that is the P0, Q0, Q1 and Q2. This is the 1 and that is the 2. Now Q0, and now we check these two set again divided into the subset on the basis of the transition table. If these set are lie into the same transition function, then lie into the same set, otherwise it is different. Now we check, now this further no division is possible. We check the transition function of the Q1 and Q2. Now Q1A, Q2, it means lie into the same set, this one, and Q2, Q1, it means same set. It means Q1, Q2 for A transition lie into the same set in set 2. It means that is the same transition function. We check for B, Q1B A and Q2B, Q1, Q2 again lie into the same set. It means Q1, Q2 lie into the same set and Q0, P1 and P2 are equal. It means no further process is going on, and this is very easy question and one step has been solved. Now how many state? 1, 2, 3 and 3 state are minimized into the 2 state. The first state is Q0 and Q1 and Q2 is the single state. Now these 3 states are minimized into the 2 state. Now Q0, Q1, Q2 are minimized into the single state. This is the Q1, Q2 is known as a B, and this is the minimization of the finite automata. All students pause the 2 minutes and try these examples. I think that is very easy example. That is a third example for the better understanding. I have told that only the 3 steps we follow. The step 1, draw the transition table of the given finite automata. Step 2, divide all the set into the 2 subset, set of the all final state and set of the final state. Step 3, all these 2 sets again divided into the subset on the basis of the transition function. Those state has the same transition function lie into the same set. Those state have a different transition function lie into the different set. Only these 3 steps we minimize the whole problem. This question asks in GATE examination 2018. So that and pause 2 minutes and solve it. That is very easy problem. And now let's move on. Now state diagram. Now this is the state. The first step, we draw the transition table. Now the Q4 is your final state and all state is the non-final state. Okay, now this transition table I have already explained that. Now what is this step 2? That is the set 1 and that is the set 2. All state divided into the 2 set, set of all non-final state and set of final state. Now this one, that is the set 1, that is the set 2. Okay, now we check these set divided into the subset on the basis of the transition function. Now Q1, Q2 and Q3 have the same transition function. So it is liable to the same set. We can check the transition function of the Q1, the transition function of the Q2 and the transition function of the Q3. Check it. Now Q1A, Q2, Q2, Q1A, Q1 and Q3, Q2. Now Q1, Q2, Q1, Q2 both are aligned to the same set. No problem. For the B, Q4, Q4, Q4 and Q4 line to the set 2. It means Q1, Q3 and Q1, Q2 and Q3 have same transition function. So it is liable to the same set, and Q0 have a different transition function than Q1, Q2 and Q3. So it is divided into the different set. You can check it, no problem. Now for a Q1, Q1 is lie into the set 1, no problem. For the A, and for the B it is Q3. Again it is lie into the set 1. It means the transition function of the Q0 is not similar to the transition function of these 3. So it is different one. In previous one, how many states? 1, 2, 3, 4, 5. And this is your final answer. 5 states are minimized into the 1, 2 and 3 states. Yes. Now Q1, Q2 and Q3 are minimized into the single state. Now this is the final answer. These 5 states are minimized into these 3 states. Okay. Now thank you. We meet next lecture for the next important topic of the finite automata.